I'm just kidding. I don't know.
Okay, that was horrible. Good morning, this is Calc 2.
That was.
Okay.
Copyright.
I know.
He's just take that to jail.
Anyway, all right, so 3.2 implicit differentiation. I don't think anyone that actually watches that channel actually watches, any math stuff. Nothing this high. They might be in like intro to numbers classes. Okay.
Now he's
Like
gonna take it
how to count your fingers and toes. All right, so finding derivative using implicit differentiation, higher order, all that other good stuff. All right, so now use implicit differentiation for this one right here. So we're gonna do implicit on this one. So let's take a look. So this piece right here is what rule? Product. Thank you. So xy minus 4 equals 0. Okay, hold on. Let me insert a page here because I need a little bit more room. So x, y minus 4 equals 0, right? So if this is implicit, okay, take the derivative. So it's going to be y plus x dy dx equals, and if I move this to the other side, it's going to be 0, right? So solve for dy dx. Are you okay?
Well, it's a y.
It's a y. I'm sorry. Okay, there we go. All right, dy dx. Oh, y'all people. Oh my god.
Move
Anyway.
the y over. Then
Okay,
y.
so now dy dx. So dy dx is going to be equal to negative y, right?
Yep.
Over x. Very good. All right. So that's one way of doing it, right? That's using implicit differentiation. So now if I go back to this one right here, solve for y and then differentiate. Solve for y and then differentiate. So this is going to be x, y. So add 4 to both sides equals 4. And then y is equal to 4 over x.
Whoa.
4 over x, right? Yes. Now, take the derivative. So take the derivative of this, so y prime would be equal to what? Negative 4 over x squared, right? So I bring it up to the numerator and do the power rule there. Okay, so, oh, dang, look, those look different, don't they? Oh my goodness. Okay. All right, you ready?
They do.
So let's take a look at the previous one, or the part C. It says, verify the results of A and B are the same. Oh, do they look the same?
Just plug in for y.
Yeah, I'm going to. Do they look the same? No, they don't look the same, but I could have this one right here is in terms of x and y. This is in terms of only x, right?
Right.
So I could replace my y with 4 over x, right? Say yes.
Yeah.
All right, so I'm going to do that. So it's going to be, so if I do that, it's going to be dy dx negative, and it's going to be 4 over x, right? Over x. Algebra that thing, so it's going to be negative 4 over x times 1 over x, right? Which gives me negative 4 over x squared.
Wait, it's negative 4 over. Oh, wait. Oh, never mind.
Yes.
Where did I lose you at?
If your y prime equals negative 4 over x.
Okay, hold on now, what?
If your y prime equals negative 4 over x squared, what happens to the negative when you move it to dy over dx?
Okay, no, I'm using the substitution. I'm using this one right here.
Oh, okay, sorry.
Because I'm not substituting y prime, I'm substituting in y.
Yeah.
Because this is in terms of x and y. And if this is my y prime over here. Okay? Since this is the y prime right here, I'm only subbing in the y for this piece right there. Does that make sense?
Yeah.
Okay. So this is the same thing. It's just this was in terms of x and y, and this is in terms of just x, right? Okay. All right, so power rule for functions is there. Okay, and there. Okay, there. All right, hey, look, there's some other stuff right here. Okay, there. Okay. All right, so differentiate using implicit. So take the derivative of this one right here. So it's going to give me, this is going to give me what? 6, right?
X, dude.
So 6x to the first, right?
Yeah, that was
Plus
like,
8y.
dy, dx.
There we go. dy dx
Here we go.
equals
2.
2. Now, if I'm finding dy dx, that means I'm isolating. I'm getting dy dx by itself on the left-hand side. So that means everything else has got to go to the right. So this is going to give me, I'm going to move that to the other side. So it's going to be 8y dy dx equals 2 minus 6x. And to get my dy dx by itself, I have to divide both sides by
8y.
8y. So my dy dx is equal to 2 minus 6x over 8y.
You got it. And there we go.
It's not bad, right?
No.
The only thing different about this is every time I do a variable that is not x, I add dy dx. Okay, so eventually you're going to get into the triple derivatives of like 3 to x, y, and z. So you're going to have to actually do, you know, you're going to have a dx or dy dx or dy dz or whatever it is right there. So it's going to be for whichever. So, or another one that we do is everything in times of time, right? When we're doing related rates and we're actually doing velocity and all that other stuff, it's actually in terms of time. So everything is going to be like dx dt, dy dt, the change in x over time, the change in y over time. That's what we're looking for right there.
Awesome.
All right, so right here, find the equation of the tangent line to the graph of the ellipse, bleh, at the point here and here. Graph the equation and the tangent line on the same set of axes. All right, so let's go through and start this out. So again, is this the same one for my last one? Yes, it is. So my dy dx is going to be, what was it?
2 minus 6x. I'm sorry. I said the wrong number first.
2 minus 6x over 8y.
Yep.
Okay, so if I'm finding the slope there, gotta plug in those points, right?
Yes.
Okay, so plug in those points. So if I'm plugging in those points for this, so it's going to be, let me see, it's 2 minus 3, so it's going to give me what? So it's negative 1 over, this is going to give me negative what?
2.
Negative 2. So it's 8 times negative 1/4, right? So it's negative 2, so my slope is? 1/2. So I have my slope of 1/2. So my equation is now going to be y minus negative 1/4 quantity. All right, so 1/2 x minus 1/2. Yep, so it's going to be y plus 1/4 equals 1/2 x minus 1/4. Subtract a 4 from both sides, so y equals 1/2 x, and if I'm subtracting 1/4, it's going to give me minus 1/2. There we go. So there is the equation of my tangent, and then I'm going to graph the other thing. Okay, so let me see. I think I have the... Trying to pull up the... I'm going to bring up the graph of it right here.
It's a very small.
Just be the P in the circle, yeah.
Okay, so let's go calculator, documents, and...
First words are P.
Okay, so I have my... So let's change this. I'm going to change it to a relation. Okay,
Yes.
so it's going to be y prime, right? No, it's
So-
going to be, what was my first one? So it was
like 3x squared.
3x squared, so it's 3x squared
Plus, is it 2y?
plus
Or 4y? 4y squared?
plus 4y?
I think so. Can anybody confirm for me?
4y squared?
I'm checking. Yeah, 4y squared equals 2x.
So minus
2x.
2x equals 0. So there is my ellipse right there.
Tiny.
It's a small one, right? Okay. So I have the ellipse there, and now I'm also graphing the what? What was my other one? So tab. So I'm gonna change this now. So now it's on relation, but I want to change it back to be a function, right? So I go to menu, graph entry, function. And my function was y equals, was it 1/2 x?
X minus 1/2.
Okay. 1/2 x minus. There we go. Enter. Here we go. So my graph is actually touching at that single point right there.
Incredible. Precision of matter. I want to see it roll. Is that an option?
No, just click A.
Keep zooming in. Enhance. Enhance.
There we go. Does that look pretty good there?
It's like Indiana Jones and
On a center?
The center's right there.
Center question mark?
If you click on it, it'll tell you what the center is.
center.
Question mark?
Okay. All right, are we okay there? Now, anyone have questions on graphing a relation?
He's just sitting there.
Click on
No, sir.
Okay, we just got to change it to relation first, right?
Right.
All right. So, we're going to have product here.
Oh, yes.
Oh my goodness.
So product here, so it's going to be, for right here, it would be product. So my f prime, so it would be, let me see, e, y, dy, dx,
Awesome.
cosine of x, right? And since it's product, it'd be a plus sign, and that would be derivative cosine is negative sine, so negative sine of x, and then e to the y, right? Equals 1. Throw away my onion.
I'm sleeping.
I did. So I don't have an onion to
Girl.
I know, to get people's attention. Are you that bold?
Me?
No,
you.
Oh, okay. All right, so is everyone okay with this? Did I lose anyone on this?
No, you did.
Okay, so now
Oh, part.
move this to the other side, right? So it's going to give me, actually, I'm-
why? Can you do it all in one step or break it up?
so e, y, dy, dx, cosine of x, and that's going to give me, so that's a minus, right?
Yeah.
So it's going to be a plus on the other side equals 1 plus sine x times e to the y, right? And I'm trying to get dy dx by itself. So now this is multiplying the e to the y, and the cosine of x is all multiplying, right?
just
So to get
divide
over
it
there,
up.
divide it all out. So I'm going to get dy dx equals 1 plus sine x e to the y over, that's going to be e to the y cosine of x. Okay, find the equation of the graph. So that means add 0, 0. So the first thing I need to do is find the slope, right? So dy dx. So when I plug in 0, so sine at 0 is
0.
0. Okay, sine at 0 is 0. So that takes care. So I'm going to have 1 on top, right?
Yep.
Okay. Now, what is cosine at 0?
1.
It's 1. What is, okay, e to the 0?
1.
So on the bottom I'm going to have,
1.
there we go. So it's 1 over 1. So I get a slope of 1, right?
Yeah.
So I'm going to get y minus 0 equals 1 quantity x minus 0. So it's going to be y equals x.
Wow. Oh my god, dude. Okay.
Take my sickness away.
You're gonna hack up a lung back there.
Okay, higher order right here. So let's find first derivative and second derivative. So let me see. First derivative. I'm going to have, let me see, that's going to give me 2y dy dx minus 2x equals 0. And so from there, it's going to give me, can I jump to one step?
Yeah.
dy dx equals 2x over 2y, which is just x over y, right? Okay, so there's my first derivative.
Alright, let's do it again.
Let's do it.
Okay, so now let's do, so I could do, watch this, watch, d,
Oh, it's like we never get to use it.
okay, right there, equals, so
Y.
it's quotient rule, right?
Yeah, so y minus
So y minus
x dy dx.
x dy dx over y squared. And so now, can I leave it like that? Say no.
No.
No, because I'm finding the second derivative, but the second derivative has the first derivative in there also, right?
Can we substitute then?
Yes, I substitute my dy dx. So I substitute my x over y wherever you see dy dx. So this is going to go up. So y minus x times x over y all over y squared. Okay, I'm kind of running through this quickly. Are you guys okay with this?
Yeah.
So am I losing anyone on any of this?
No.
Okay, so I just clean up, right? So clean up the whole thing. So it'd be, let me see. That's going to turn into y squared minus x squared over y all over y squared over 1. See what I did there? X squared over y, right? And I turn this into common denominator. Okay, so go ahead, multiply by the reciprocal. If I multiply by the reciprocal, it's going to be y squared minus x squared over y cubed, right? Because I'm multiplying by the reciprocal, y cubed. So I have everything for my second derivative in that term right there. That's terms of x's and y's.
On the AP test, are you expected to simplify?
You actually have to go to this point right here.
Okay, that's what I was expecting. I was
Yeah,
like-
you have to go to this, especially when it says express this in terms of x and y. So that means,
Oh yeah, so no dy dx.
yeah, no dy dx's. So, and it's y prime, y double prime. So it's a different way of writing it. So this is actually d squared y over dx squared. So it's, this is the second derivative. This
Yeah.
notation for the second derivative. It's the same as saying y double prime.
Yeah.
But I don't like actually when I'm doing these problems using the primes because you don't know where it's going to end up at, and it looks a whole lot like just y to the first.
Right.
So you know when you see that dy dx right there that needs to go out. Does that make sense?
Yes.
Okay. So that's a good thing to always do. And where am I at? Blah, 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 rational, blah, 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 defined. All right, so, hold on. I think I am
Wow, we're done.
pretty close, yeah, all right. Okay, so, this one right here says take the derivative with rational exponents. All right, same thing, right? So it's gonna be x to the positive 1/2, take the derivative, that's gonna give you 1/2 x to the negative 1/2, right? Which cleans up to be a 1 over 2 rad x, or if I was going to, rationalize or anything, but I'm not going to. I don't care. So,
This is rational.
okay, so let's jump down to C. C, that's gonna give me what? So 5/2 x to the 3/2. Because when I subtract 1, I'm subtracting 2 over 2, right? And then, guess what, that's it. Are we okay? All right, remember that issue I had on that problem the other day? It was so weird. I had to go back and do everything the long way. And I sent you guys a video of me fixing that one problem on the notes. Do you guys get that?
No,
Oh.
but I can watch it right now.
Yeah, because it was that weird one. It was like 1/2 to the x squared minus 1.
Oh yeah, no, I remember that bit.
Okay, yeah, it was weird. And, oh crap. Ah, dang it, I didn't mean to do that. Anyway, all right. So yeah, I fixed it because it was just weird. All right, so now, what's this one gonna be?
Chain rule.
Yeah, chain rule, right?
Yeah.
Okay, so chain rule. So let's do chain rule off of this. So it's gonna be what? So 5/3, all the quantities, so it's S3 minus 2S plus 1 to the
2/3.
2/3, because I'm subtracting 3 over 3, right?
Yeah, I was thinking of 2's again.
Yeah, 2/3 times the derivative of the inside,
So 3s squared minus 2.
3s squared minus 2. There we go. And just leave it like that. It's nasty, but you know what? Leave it alone. All right, so part B, what would B be? If I was to rewrite B first, this would be
1/3.
x to the 4th, right, minus 3x plus 5 to the
1/3.
1/3 power. And then chain rule again. All right, do you guys need to go through and do the rest of these?
No.
No. Okay.
Sit here, top one.
All right, there we go.
That's a wrap.
Don't forget, like and subscribe.